Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we would love to have you join our show today on this beautiful Wednesday. If you're in Bakersfield, give us a call. The number is 636-4357. If you're in San Luis Obispo, you can even call us there as well. The number is toll-free, 866-636-6284. You can even email us your math question. Now, if you do that today, make sure you get it in soon so you don't have to wait a whole weekend before we come back next week. The email address is dothemath@kern.org. You can watch the show online, dothemathonline.net. And of course, if you have any type of social media, we are on Facebook, Instagram, Twitter, and YouTube.
All right, well, you know what? We have a couple of students waiting online to go ahead and do some math problems this afternoon.
Good deal.
We have a very special guest in studio. We'll be heading out live, out and about with Marylou. She's at Stria today. But before we get to any of that, let's first take a look at today's Math in the News. All right, so have you heard the saying, everything has a price?
Definitely. Like there's no free lunch, everything has a price.
That's right. Everything has a price.
Yep.
And it reminded me because I was wearing a kind of like a sweatshirt the other day, and we were out playing pickleball, and the guy was like, hey, I'll take that. And I was like, for the right price, you'll take that. That's right. Everything has a price.
Yep.
Not saying I wouldn't sell it, but it would have to be the price that we're both happy with here. So everything has a price, and we're going to get to that in a moment. But first, we want to talk about loyalty. Okay. As far as being sports fans, we stay loyal to our teams.
Usually that is the case.
That is the case, because sometimes you hear people, they go, well, you know, I like this team now. Well, why do you like them now? Well, they're winning now. Okay, well, that's not the way it's supposed to be.
Right.
Yeah, for the fair weather fan, I guess that's fine. You go on with the teams and applaud them and cheer for them as they continue on their way. For some of us, you have to stick with a team through hard times.
That's right.
And we are probably like in the middle of the basketball season for NBA right now. Now, do you have a favorite basketball team? One that you
I do like the Warriors, yeah. My boys like the Warriors, so we have to be Warriors fans.
All right, so those guys are doing pretty well again.
Yep. They had a little slow start there, but they're definitely coming on. This is the right time of the season to get hot.
All right, well, we can take a look at their record in just a moment, but we're going to take a look at a not so good team right now. So let's take a look at this came out of yesterday's newspaper. And growing up, you know, I was a Knickerbocker fan, you know, and used to go to the Madison Square Garden, see the Knickerbockers all the time. And in the 70s, they had quite the teams.
They did.
I mean, they were powerhouse.
Yep.
And even for a bit after that, but we can see right now, they're not so great. Right?
New York's having a hard time
10 and 35.
Oh, yeah.
23 and a half games back. The Knickerbockers haven't even made the playoffs in years, and all you have to do to make the playoffs is basically be 500.
Okay.
Okay.
Yeah.
So we can take a look at this, and you can see that, right? Every other team in that conference is going to be in the playoffs, probably.
Right.
Right. Now we can go to. Oh, let's see. You guys, I folded it right at the bottom there, but Golden State atop.
Golden State, top of the Pacific Division.
There you go.
All right.
Now I know. Hey, there you go. I know a lot of kids, Clipper fans, Fakers fans. Oh, did I say Fakers on TV? Lakers. Anyway, I just like to mess with people because I know a lot of friends that like the Lakers. So they look playoff bound, 25 and 23.
Right.
And you would think with LeBron, the team is going to be in the playoffs.
Right.
Okay, even though it's his first year there. But the reason I bring this up is because, as I said, everything has a price.
Ah.
Now, before we go ahead and show this, so I'm going to have Brian take us off the camera there for a moment so that we can't see this. So we don't want to see what's under the Elmo right now. So I was astounded when I saw this in the magazine. I was simply shocked that somebody would actually pay for this.
Okay.
Somebody sold basically their fandom. I'm a fan of the
okay.
Knicks.
All right.
I don't want to be a fan of the Knicks anymore. I'm going to sell you my being
Your
a fan.
support for a different
Right.
team? Oh,
And
my
how much
goodness.
money do you think this went
Wow.
for? How much money do you think somebody would pay to go, I'm going to leave you of being a Knicks fan?
There's so many logistics too. Like forever?
I would
Forever.
imagine so.
Release
I'm done
your
with the team.
allegiance to the team.
Well, let's just go ahead and take
Wow,
a look
yeah,
at
I
it. I
gotta
don't want to put
see
you on the
this.
spot. And a Laker fan bought it. A Knicks fan auctioned off his fanhood on eBay, and a Lakers fan paid $3,450 for it.
Oh my gosh.
So somebody paid over $3,000. They paid this guy
Yeah.
to say, all right, you don't have to be a Knicks fan anymore.
To no longer be a Knicks fan.
Yeah, I mean,
Maybe to be a Lakers
as simple
fan.
as that. Maybe I ought to put that on there, see if, hey, give me a couple of grand.
Everything has a price.
That's why I brought it up.
Yep.
Everything has a price.
That's right.
And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors most Tuesdays and Wednesdays throughout the regular school year. And in studio with us right now, we have Debra. How are you?
I'm good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Ronald Reagan Elementary School and I'm in 5th grade currently.
5th grade going well?
Yeah, I really like it.
Is it really easy?
Yeah, kind of.
Yeah, it is really easy. Wait until you get to 6th grade. And then guess what? Wait until you get to 7th grade. Then you're going to have more things to worry about besides just schooling. It's going to be like, oh, look at all these new people around. And then when you get to high school. But you will have somebody to help you through all of that because you have somebody that has already gone through all of that stuff ahead of you, right?
Yeah.
Why don't we say hi to that person right now? Say hi, Donya.
I don't.
Because I know that at some point she's going to be watching this program, right? So we'll just give her a big shout out right there. So what are some of the things that you like about 5th grade that make it enjoyable and fun?
It's really fun. The math is something, honestly, math is definitely my favorite subject.
Okay, so you like that.
Yeah,
Good.
It's probably one of the first subjects that I started learning, of course, besides reading and other stuff. But it's really nice, the math. I like how we're learning fractions and decimal points. That's something that I really enjoy doing.
Right, because in 5th grade, I think most of your time in 5th grade is going to be dealt with fractions, decimals, and percents.
Yeah.
And going between all of those things. So, you know what, we've got about 2 minutes, 3 minutes before we head out to our live shot. So why don't we head on over to the board real quick, you and Scott, and we're going to take a look at one of the problems that you're working on in your book. And we'll work on this together, as well as everybody at home. So here's some information, and you guys can kind of look up on the screen at the same time. So a postcard has an area of 24 square inches. So you might want to, so Scott, if you want to just write these down. 2 enlargements of this postcard have areas of 54 and 96.
Okay. Interesting. So we're going to make an enlargement of that and make an enlargement go there. Wow.
In all of the postcards, the length is 1.5 times the width.
Ooh.
So the length is
interesting.
always 1.5 times the width. Now, over on the right side, if you'd like to, we'll just go ahead and write down these options because you can mark all that apply. So there may be more than one correct answer.
All right.
So the first one is 6 by 9, 10 by 15, 8 by 12, 6 by 12, and 4 by 6. So mark all that apply to that. So we're looking for 24, 54, or 96.
There are a lot of things to think about.
Yeah.
Where do you want to start, Deborah? Where do you want to start with this problem? There's a lot of stuff that you can think about in this one.
Do the multiples of all the numbers.
Okay, interesting. I like that idea there. Tell me a little bit about what this means. 1.5 times the width. The length is 1.5 times the width. Like, how do you go about thinking about that one?
You would have to multiply 1 and 1/2 times the width to get what the length, what the length is.
Right. So if you had, let's say that the length was 2 What would the width be? Can you think of what that would be? 1 and 1/2 times 2?
0.5?
Almost. Multiply it instead.
1 and 1, 2.
Yeah, so if you multiply it times 1, you'd get a 2, right?
Yeah.
What's half of 2?
1.
1. And then 2 plus 1?
3.
3, that's right. So if you had a length of 2, the width would be 3.
Okay.
So that has to be the relationship there. Maybe we can look at the answers and make sure that all the answers at least have that relationship, because if they don't, we don't even have to figure out if it's going to work here. We can cross that one off, right? So 1.5 times 6, is that 9? In other words, if you take half of 6 and add it to it, what's half of 6?
9.
No, half of 6 is?
I mean, not 3.
3, and then
add
6 plus
that,
3
9.
is 9, so that one works. So we know that one's going to work. We don't know if it's going to work for these numbers yet, but we know it's going to work. What's half of 10?
5.
5, and 5 plus 10?
15.
15. Hey, that works too. How about this one? What's half of 8?
4.
And 4 plus 8?
12.
12. So far, so good. Half of 6?
3.
3, and 3 plus 6?
9.
Oh, that's not going to work. So at least we know one of these, it can't possibly be the answer. Last one. Half of 4?
2.
And 2 plus 4?
6.
Good. So we're now down to 4 instead of 5 answers. So that's a good way to start, right? Then we got to figure out if those numbers end up being any of these, right? So 24, that was the original number, 54, and 96. So let's see if any of these numbers multiply to be those numbers. Can you find the area? Why don't we just come up with all the answers over here, and then we'll compare them over there. So what do you got on the top there? What's 6 times 9?
54.
Can you write that next to it? Good deal. And that would be in inches squared, right? Because we have square inches there, doing some measurements. What about 10 times 15?
150.
Okay, write that over there. Yeah, and what about 8 times 12?
96.
Uh-huh. Looks like we're getting some familiar numbers here. Last one, 4 times 6?
72. Oh, or no, 24.
Yeah, we can skip that one because remember we crossed it off at the beginning, right? We had 24. Good. So now we can kind of line these up. The very original dimensions could have been E, right? They could have been corresponding to the first number.
Yes.
Which one corresponds to the 54 inches?
This one could go to this.
Uh-huh.
and
Once you draw an arrow,
54.
circle the C or circle the 96 and draw an arrow over there. 54 goes to the middle one. Weasel your way over there. Good job. And then 96. Yeah, there you go. Good job. It's okay to be a little messy in math because we like to see that work that's going on there. Mr. Crushai, what do you think? Did we do what was asked on that problem?
There you go. Nicely done.
Nicely done.
Congratulations. First problem of the day is all over with. 636-4357 is the phone number. We do have phone tutors available until 5:30 right now. We have an opportunity to head out live with Marylou at Stria.
We are live today at Stria, and I am with founder and CEO Jim Damian. How are you doing?
Good, Marylou. How are you?
Good. Can
Good.
you give us a brief history of what you do here?
Sure. Stria is a business process outsourcing company. And so what that means is large customers outsource processes to our team. So rather than do the work themselves, there's certain back office tasks that they rely on Stria to execute for them.
Now, you are the founder.
That's right.
Can you kind of give us a little history how you got to this business?
Sure. Well, I'm originally from Tehachapi, so born and raised here in Kern County. Went away to school, went to college, went to grad school, and became a social worker. And I was working in the social work community, working with children actually. And I would get calls from police officers and other social workers wanting to know about various cases and kids. And I'd go to the filing cabinet and I could not find the information I needed. So I knew there had to be a better way. And that's when I got introduced to paperless records management and information technology.
So obviously, you have to be really organized in order to do this. What were the baby steps where you started putting it all together?
Well, the most important thing was talking to our customers, understanding where their pain points were, because their documents may be different, whether it's healthcare or law or banking, they have different needs. So really just talking to the customers, understanding how they're currently organized, and then thinking through how can we use the existing technology and our staff to make their processes better. And a lot of that, especially in the early days, had to do with scanning and taking huge amounts of paper and scanning that paper into an electronic system.
Now, did you start looking around at businesses, or did you start playing around with scanning it and seeing how long something would take to scan and file it electronically?
Yeah, I mean, we tested everything, right? When we started the business, we would figure out the best technology, the best hardware, and then we would take that to our customers and go, hey, we think we can improve your processes by using this approach. And in general, people were pretty receptive.
So I'm thinking about my own files, okay? When I have my files in my Google folder, it's a mess.
No.
So obviously, when you're doing this, you have to kind of make sure everything is there. How do you go about doing that?
Actually, when we're doing projects like this, we have a whole team of people that their whole job is to make sure everything is done right and that no steps are missed. So believe it or not, we have 22 steps that one piece of paper has to go through before it's delivered back to a client in electronic format. So between our humans that are running the scanners and the computers and artificial intelligence, we're using those two things to make sure nothing gets missed and everything is processed and given to the customer how they want it.
Okay, so I come in, I have a whole file cabinet with all of my math plans, and I give it to you because it's all paper and I need it all electronic. Where do I go? Do I just walk in with all of my boxes and say, hey, here you go?
That could work. Most of the time, people will call us, and we will go out and look at that file cabinet. And if it's math plans, I'll read it because I like math, right? But then we'll come up with a process to pick that up. Clients don't have to bring anything. We have staff to take care of all that. Most of the time, they point us at a series of cabinets or a warehouse, and then we develop the plan with them, and away we go. But it's real easy. From a client's perspective, you don't have to do much. You just have to call us.
Wow. So we don't even, I wouldn't have to bring it to you. You guys come to me, you pick everything up, and then when you deliver it, obviously, it's not going to be on a CD, is it?
Most of the time, it's electronic. It's in the cloud. People using Google or other electronic document management systems, we will put the content, the electronic images right into that system. So we do have clients who use Google.
Yeah.
So we can scan those, math lesson plans and digitize those and put them right back into Google or whatever system the clients happen to be running. But typically, it's not on CD.
Okay, so you started here in Bakersfield. Is this the only place that you have, or is there other offices?
This is our headquarters. So we're here, but we have other offices throughout the state. We have an office in Orange County, and we actually have an office in Las Vegas, Nevada. So we're here and we're local, but we're starting to spread our wings and move throughout the region a little bit.
Do you know about how many clients you currently have?
We have about 26 clients. So we keep our client list very small, and we just try and really develop those relationships and try and just be, absolutely add a lot of value, right? So we don't want to be all things to all people. We want to have a select group of clients that know us and love us and that we partner with to solve problems.
Okay, so you have a lot more to show us. You're going to actually take us in the back, and we're going to see a math problem with your business. So we're going to send it back to the studio to Mike and Scott, and we'll see you in a little bit.
All right, thanks for that, Marylou. Hey, we do have phone tutors available until 5:30. We have Debra in studio with us right now, and right now we need to have Elias, a student from Reagan Elementary, give us a call back, as well as Minna, a student from Miller Elementary, give us a call back because for some reason we got disconnected. So we need Elias from Reagan and Minna from Miller to give us a call back. That way we can get you guys on air. We can work out your math problem and help you out a little bit with that. In the meantime, we are going to have young Debra continue working over here.
Hey.
So let's take a look at another one of the problems that you're working on. And here we go. So the table shows how many hours some of the part-time employees at the toy store worked last week.
Okay.
All right, so we'll leave the graph up there. So we can see that Conrad worked 6 2/3, Giovanni 9 1/2, and Sally worked 10 3/4. Here comes the important information. This week, Conrad will work 1 3/4 times as long as last week. So we might want to just figure out how long that's going to be.
Okay.
So Conrad did work 6 2/3, and now he's going to work 1 3/4 times as long as that.
Wow. Okay. So we got 6 2/3, and he's going to work 1 3/4 times as long. So without even looking at the answers, we're at the possibilities. We're going to go ahead and work this one out. Where do you want to start, Debra?
Making that a whole nut fraction.
Okay. Give it a shot. See what we do there. Wonderful. Where the heck did that 20 come from?
I multiplied these two and then I added.
Good. So you got the old times plus going on, right?
Yeah.
Good job. 3 times 6 is 18 plus 2 more is 20. And I like how you kept the 3 on the bottom. Walk us through the next one. What are you going to multiply that by?
And then I'm going to multiply 4 by 1, which is 4, and then add 3, which is 7.
Good.
So 7 over 4.
And you kept the 4 on the bottom too. Good. All right.
Then 12
12 on the bottom, yeah.
and 140.
That's it. Now, are you familiar with the idea of cross-canceling at all? Have you done that before?
No.
Okay, well,
Oh,
maybe
yeah, cross-canceling.
you can cross-cancel. Just makes your numbers a little bit smaller. You don't have to do that. 140 over 12 isn't wrong, but there'll be some reducing necessary. And maybe if you cross-cancel, we can make the numbers smaller. Oh, here she goes, little cross-canceling. What are you dividing both of those numbers by?
I am dividing it by 4.
Good. All right, so now we have some smaller numbers. That's kind of a good deal.
Yeah.
It'll make things a little bit easier when you go and divide them back out to make another mixed number, right? Okay, so what do you got now?
35
35 on the top, 5 times 7, good.
over 3,
And 3. Now we got to make it into a mixed number,
which
right?
equals 11.
Okay.
Because I divided this, I thought that 33 is the closest.
Right. 3
so
times 11, 33.
And there's going to be 2 more left over.
That's it.
So 2 over
11 2/3. Anything resemble that at all on that page? 11
Well,
2/3.
let's take a look. We have 7 1/6, 12 2/3, and 11 2/3. So it looks like that's one.
Hey, we got one of them.
Let's move on to the next one.
All right.
Giovanni works 9 1/2.
Okay.
And Giovanni is going to work 1/3 as long as last week.
1/3. So now, just to make sure that we are logically correct, make sure this answer is going to make sense. You see how the first one we did with Conrad, right? He worked 6 2/3 hours, and then he's going to work 1 3/4 hours as much this week, right?
Yeah.
So in other words, this number is more than 1, and the answer ended up being more, right? He worked more this week.
Yeah.
Tell me about this next person. Is this person going to work more or less?
Less.
Less. So let's make sure when we get to the end of the answer that answer is less than 9 1/2.
Yeah.
Okay, what are you going to do now to start this one off?
I'm going to make it a whole number again,
Okay.
which is going to be 9 times 2, which is 18, plus 1,
Good.
which is 19.
So you're making this into a nice big old improper fraction. Good.
And the 1/3 just has to stay as 1/3.
Now, anything you can cross cancel here?
No.
No, not this time. But we always want to look just to make sure.
Yeah.
Oh, good job putting that time sign there.
And then it's going to be 19 over 6.
Good. So far, so good.
And is that you have to simplify
So you're kind of doing some
it.
division in your head there, I can
Yeah.
tell, right?
3, and
Good.
then because 6 times 3 is 18.
Good.
There's
And
gonna
so
be
there's one more left.
over.
Yeah. Now, does this satisfy our requirement? Is 3 1/6 less than 9 1/2?
Yeah.
It is. So he worked a lot less in this one. Hopefully, 3
You
1/6
know
is
what
one
we
of the
need to
options.
do? Yeah, you know what? Because looking at the screen, I can see that there was a 1 1/3.
Oh, okay. Gotcha. Well, this makes it kind of interesting. Now, here's another way to do this. Because we didn't know about this 1, right? We multiplied 9 1/2 times 1/3,
Yeah.
right? And we got that answer. We forgot the 1 part. What's 9 1/2 times 1?
9 and
9 1/2. So could we do this? Can we just add in 9 1/2? Because 1 1/3 is 1 plus 1/3, right? We already did the 1/3. We could do the 1. Interesting way.
So
Because we
add
happen to
these
forget it, instead of starting over, you could add them together, right? See what you can do here.
1/2 could equal 3/6.
Oh, I like what you did there. Good choice.
And 3 plus 1 is 4.
Good.
6. 3 plus 9 is 12.
Good, and
we
a little
can
bit of reducing,
simplify it to 12 and 2/3.
Wonderful. Now we're really hoping that 12 2/3 is part of the deal, right?
There you go. And wonderfully done. I appreciate the simplifying and talking your way through that. So nicely done on that. Let's take a look at the last one. Sally. Sally worked 10 3/4
Oh my gosh. 10 3/4.
and will work 2/3 the number of hours.
You sure it's not 1 2/3?
Easy now. I gave you 1/3 because I wanted to see if you guys were going to be able to come back and add that.
I like it. Here we go. I'm going to give you a little bit of room. Have at it. So, final answer should be more or less than 10 3/4.
Less.
Should be less, that's right. We will hope that's the case this time.
So should I add 1 or no?
Nope, not going to be a 1 this time.
Okay.
If it is, we'll be prepared. It won't be a problem.
4 times 10 is 40.
Good.
Plus 3
Yep.
is 43.
Good job.
And then 2/3 will stay as 2/3.
2/3 will stay as 2/3. That's it.
Can I erase them as this?
Sure, yeah, or you can just make it. Why don't you just go down here? We always like to see the work. As a math teacher, I always like to say, I don't mind how messy it is. We just like to see what's going on there.
And it will equal 12 and, or 86.
86,
over
yeah.
12.
Now, did you want to cross cancel? Because you can do a little bit of cross canceling there. We can
oh,
maybe skip
yeah.
it this time. Stick with 86 over 12, and we'll just reduce
We
at the
can
end. How about
divide
that?
it
Yeah, that's fine.
by-
So in your head, you're thinking 86 divided by 12.
We can first divide it by 2, or
Oh, you want to divide it? You want to reduce it first? That's a great
Yeah.
idea. Why don't you divide everything by 2? Good idea. So if you divide it all by 2, you get 43 over 6. Oh, that's nice because it's real close to what 6 can go into, right? 43 divided by 6 is 7, and there is 1 left over. 7 and 1/6 is less than 10 3/4.
Yes.
And I think that's on the list as well.
All right, let's take a look. See one at the bottom. We did have 7 and 1/6 right there. Now,
Nice.
besides working through all of those problems, let me just move it up a little bit so that you can see all of the different options.
Okay.
Once you figured out the first one, and you saw that that was, what, the 11 and 2/3, I think?
Yeah.
Right? So taking a look at that, you would have had Conrad go down to 11 and 2/3. Giovanni, you knew, was what? The 12 and 2/3?
Yeah.
Yeah.
Okay. If you were looking at the paper the whole time working on it, did you even have to solve the third one?
No. Wait, let me see. Which
As
one was
long
the
as they
third
said
one?
that those options are the only options.
Because
you
you've
have,
got 3
right?
names and 3 hours to
Yeah.
cross them with, right? We
Yeah.
don't even need to do the third one. Do you see how that works? Because there's
Oh,
only
yeah.
one option left.
There's
There you
only
go.
one
So
left.
that way you can save yourself a little bit of time if you're confident you've got the first 2 correct.
Right.
Nicely done right there. Well, for your hard work, I've gotten hungry over that, but we're going to award you with a meal at our friends from Grillin' Burger. So congratulations on that. Hey, we do have phone tutors available until 5:30. We'll have Scott erase the board. We'll have Debra come on over here because Minna, I believe we have on the phone right now. How are you today, Minna? Hello, Minna.
Hello.
How
Hi,
are you
Minna.
today?
Good.
And you are the young lady that was on the program yesterday, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. Francois, Carla, and Tommy are members of the same family. Carla is 5 years older than Francois. Tommy is 6 years older than Carla. The sum of their 3 ages is 31 years. How old is each one of them?
Woo! The sum of their 3 ages is 31 years. Is that what I heard?
Yes.
Okay, and the rest of it, you're going to have to slow down a little bit for me. So I heard Carla is 5 years older than Frank. Is that right? Something like that?
Yeah, something. Yeah,
Okay.
Francois or something.
Oh, Francois. We're just going to give him
Francois.
Francois. Ho, ho.
Francois.
Ho, ho.
There we
All
go.
right. Tell me the second part of the problem, please. The second part is the
Okay.
one I missed. Can you tell me that second part?
Yes. Tommy is 6 years older than Carla. The sum of their 3 ages is 31 years. How old is each one of them?
Ah, wow. Okay, so we have Carla and Francois and Tommy, and these 3 people, we'd like to know how old each one of them is. I wrote a little bit of an equation here for each one, just to make things a little more simple, at least in my mind. So I'm thinking that maybe you might have done the same thing. Did you write any small equations to make sure that you could compare each of their ages?
No, because I didn't really know how.
Yeah, it's kind of an interesting problem, and there's lots of stuff going on here. So here's what I did, just to make it nice and simple. I translated in my mind what you said out loud, which was Carla is 5 years older than Francois, right? Or 5 years older. Yeah. So what I wrote on the board is C Carla equals F Francois plus 5, just so we can make it
Okay.
into math. Okay. The next one, see if you can say out loud what I've written on the board. Tell me in that second sentence, how do we make that into an equation? It says Tommy is, right?
Tommy is C plus Carla plus 6.
Good for you. Tommy is Carla plus 6. That's exactly it. Good. So we have a couple of things that we can add up here, right? And if you added them all together, right? So in other words, Tommy plus Carla plus Francois is 31. The problem is we have 3 different letters, and it's hard to do a problem when you have 3 different letters because you don't know what any of them are. We would like to have all one letter. So we'll see if maybe we can put this all in one letter. Now here's the interesting part. Are you ready? We're going to do this. I think that we're going to go ahead and keep F. We're going to solve for how old Francois is first. We're going to keep the F there. So what
Okay.
can we put in place of C that has an F in it? Comes from our very first equation.
Wait, can you repeat that?
Yeah, the question is, what can we put in place of C? The very first equation said C equals F plus 5. What can we put in place that, instead of writing a C, what can we put there instead? I'll give you a little hint here. I circled it here. We're going to go ahead and replace it with F plus 5 because it says that they're equal, right? So
Yeah.
instead of writing a C, what I can write is I can write F plus 5. In other words, Francois plus 5.
Okay.
Instead of writing Carla, we can write Francois plus 5. Now, the last one gets even more interesting. The nice part is, so far right now, we have T plus F plus 5, Francois plus 5, plus Francois' age equals 31. So now we're only down to 2 letters. It's a good start. We would like to get down to just 1 letter. So we need to be able to replace this T with something that has an F in it. The problem is,
Okay.
our T has a C in it, right? C plus 6. We wrote that down.
Yes.
So we got some interesting things to do here. Here's what we're going to do. Instead of writing this C here, where it says T equals C plus 6, I'm going to do the same thing we did in the other equation. I'm going to put the F plus 5 there. So I'm hoping you can see what I'm doing here. Here's what's going to happen.
Yeah.
T equals C plus 6. No, we're going to take out that C. We're going to do T equals F plus 5, Francois plus 5, that part right there, plus 6.
Okay.
So hopefully you can see what I substituted in there for C. Does that make
Yeah.
sense so far?
Yes.
Okay, so now look, if you take this big old thing and put it in here for T, then we will have one big long equation and we will only have 1 letter. And that will be something we can solve. Are you ready?
Yeah. Yeah.
Okay, so we're going to simplify this. What's 5 plus 6?
11.
Good. So instead of writing T, what can I write? F plus
5. Or 11.
11. Good job. That's exactly right. F plus 11. We found out that's Tommy's answer, or Tommy's age, right? And then we're going to do plus F plus 5. We found out that was Carl. Can't remember what C is.
Yeah.
Plus-
I think it was Carla. Yeah.
Carla, there you go, I was close. Plus Francois, and at the very end we get 31. So now you have an equation with all letter F's in there. How many F's do you have in this problem?
3.
3. So we're going to put 3F. And now let's add up all the numbers. What's 11 plus 5?
16.
Good. Plus 16, and that equals 31. You want to tell me where to go from here? 3F plus 16 equals 31.
So should we subtract 16 from 31?
Good for you. Nice job. We're going to do 16 over here and 16 over here. I really like the way you said that. We're going to subtract 16 from 31. So we get 3F because these go away. What is 31 minus 16?
31 minus 16 is done.
I can hear you thinking. That's good.
15.
15. Good job. And the very last step, what are you going to do with that very last step?
Divide
Divide
by 3.
Well done. I'm very impressed with what you've done here so far. So what is 15 divided by 3?
5.
5. Okay, so we found one of the ages. We found how old Francois is. What about the other
Yeah.
people?
I don't know.
Well, go way back to the top, right? Go way
Yeah.
back to the top. We want to know what Carla is. It said Carla is Francois' age plus 5.
Yeah.
So now we can
So-
put 5 in for Francois and add
So
5
she's
together. Yeah, so Carla's 10, right?
Yeah.
Then we had this really neat one right here, this F plus 11. That was Tommy, right? Tommy was
Yeah.
Francois plus 11. So put a 5 in there for F. What's 5 plus 11?
5 plus 11 is 16.
16. Looks like we got all the ages we need. Tommy is 16 years old, Carla is 10 years old, and Francois is 5. Nice
Okay.
job. I like that problem.
There you go. Got them all. I had to make that problem up, put a little Francois in there because I know that Minna's studying French, so we put that in there. Anyway, congratulations. You got yourself a ticket courtesy of our friends at the Maya Movie Theater. So hopefully you have an opportunity to go use that. We do have phone tutors available until 5:30. We'll do some more work with Debra. We'll do it all right after this. Today we're at Del Vista Math and Science Academy, home of the Dragons, and we're here to... All right, today we're at Del Vista Math and Science Academy. We've got some 4th and 5th graders, and what you guys are going to do is you're going to work in pairs, and what I want you to do this time is I want you to, together, make one thing, okay, with the sticks, all right? So can you make anything that is 3-dimensional? Like, can you build something high with those sticks the way they are right now? You could, maybe, but is it going to get very high? Not really. So what I want you guys to do is it doesn't matter if it's just flat, 2-dimensional, or if you add a little bit of height to it to make it 3-dimensional. I'm going to give you a couple of moments. Make something with the sticks. All right? So you and your partner together make something.
Why not make it a little high?
How are we going to stand it up?
You can find a way.
Yeah, that'll work. It'll be a little bit though.
Yeah, that's fine.
Keep on putting them together.
Maybe put it a little more together.
Because it said 3-dimensional, so it's 3 dimensions.
Let's move this cart over. Oh, we're destroying it.
What are you girls up to over here?
We didn't have enough for a house, so we're trying to, I don't know.
Could you make a smaller house then?
Yeah.
Okay. So is this the house now, or do you need to modify it a little bit?
We're gonna
Mix it up a little.
Change it up a little bit? Yeah. Okay. And what are you guys doing over here?
A triangle.
Oh, you're making a triangle. All right. And what's different about this triangle than just throwing 3 sticks down there?
It has height.
Right, it's got some height to it, right? Yeah. Okay. What kind of a triangle would that be?
A regular triangle.
A regular triangle. What makes it regular?
So all the sides are the same length.
All the sides are the same length, right? And what else?
All the angles.
All the angles are what?
The same.
The same. And what kind of angles are they?
Acute.
There you go. And what are acute angles? What do the measurements have to be?
Less than 90.
Less than 90. And in this example, what are they?
Look, 60.
There you go, 60 degrees. Okay. What kind of angles do you guys have here?
We have
90.
You have 90-degree angles, right? What are those called? They're not acute angles. If it's 90 degrees, it's a
Right angle.
right angle. There you go. And the house is underway?
We're still, working on it.
As you are building the foundation for the house, what kind of angles are right there?
Right here?
Yeah.
There could be a 90-degree angle.
Yeah.
Those are 90-degree angles, right? Okay. So continue working on the house. The kids at Del Vista Math and Science Academy working with the sticks just to figure out some different objects that they can make, and we'll have them do a specific task when we come back. Once again, a big thanks to all of the staff and students at Del Vista Math and Science Academy. We had a wonderful visit when we were out there. We'll go once again out to Stria and visit with Marylou.
Thanks, Mike. We are back live at Stria, and I have another guest with me, Jared Harris.
Yes.
How are you doing? Can you let everybody know what your title is and what your position is?
Hi, I'm Jared Harris, and I am a document management specialist here at Stria HQ.
And what does that entitle?
It entitles a lot of different things. I do various work here, but my main default job here is QA, which is known as quality assurance.
And what does that exactly?
My job specifically is to ensure that the documents that we process are legible and that there's no sort of folded pages or anything that keeps the documents from being looked at.
Okay, Jared, how long have you been here?
I've been here for about 2 years now.
And what brought you here?
Before this, I used to work as a server at a sushi restaurant, and also doing college on the side a little bit. And I saw this job was available, so I, gave it a chance. And at first, I was part-time, but over a course of about a year, I became a full-time employee. So this is
So you like techie stuff, yes?
Yes, I do. Yes, I do like working with technology and just kind of learning about different things, software, that kind of stuff.
Okay,
hardware.
so I was talking with Jim earlier, and I was saying about if I'm a math teacher and I have all these files of math.
Yes.
So your company's going to come, pick
Yes.
up all my files.
Yes.
Can you kind of show me where you go with that?
Absolutely. I think we should first start with this flatbed scanner I have right here. And this is for mostly for image replacement, and it also does have the feature of X-rays.
Now, this looks like a scanner I would have it at home.
Yes, definitely. It's your typical scanner, and it does images one by one, essentially.
Okay.
So let me go ahead and show how this works. So I have my software here. I'll go ahead and start the capture, and right now it's going to light up and start scanning documents one by one.
Now, the paper you put down,
Yes.
I could see when the light goes through, it has a barcode. What is
Yes.
that for?
This barcode is to signify when a document begins and when a document ends. So go ahead and put this next one in. And this is to, signify when a folder starts, when a folder ends, because we have tons of different folders and lots of paper that's,
So
filling it.
is this, when you're scanning it, obviously starting with this,
Mm-hmm.
it's telling you everything that you're going to be scanning will go all into that one folder, correct?
Yes, yes.
Okay.
So if I had another two of these, it would start a new folder. If you notice right there on the screen, it'll show the
doc,
folder and the
okay.
doc.
Now, what if the scan is bad? It's unreadable.
Well, if the scan is bad and it's unreadable, we will do a rescan. Essentially, we'll do it in color. Maybe if the text is not good enough, maybe change the settings. Maybe the brightness needs to be raised or lowered, or the contrast.
Okay, so I have all these math,
Yes.
okay? Just boxes of math papers.
Yes.
Would this be the best thing to do for that, one by one?
To be honest, no, because this is typically for certain pages that need to be replaced. So if you had a lot of documents that need to be scanned, I think it would be best if we used our other scanner that I actually have over here
Okay.
to the right of me. So let's go ahead and check that out.
Okay, so this would be more smaller, one by one.
Yes,
things.
precisely.
Okay, so all of my math boxes.
So let's go ahead and check this one out. So this one is for mass production.
Okay,
So like you were mentioning, if you have a lot of documents and you want to get through them quick, this would be the choice that you would go with for scanning documents. So I'll go ahead and load it up for you guys.
okay, so everything gets loaded on the bottom, and
Yes.
what I noticed is you're putting in actually sideways.
Yes.
Instead of vertically, you're putting
Yes.
them in horizontally. Why?
Yes. That is because it is more efficient. We'll get more pages through the scanner, and it definitely does a lot more in a lot less time.
Okay, let's see how this works.
So let me go ahead and start this.
And it's the same thing. I see you have the two papers on top, so it knows
Mhm.
where it's starting and putting into the file, correct?
Yes, exactly. So go ahead and push start here, and it should go through.
It almost looks like a copy machine. Oh, wow,
Yeah,
look
it
at
does.
that.
Yeah, check it out. It's
Way faster.
It's a hard-working machine, that's for sure.
So how many pages will this put out?
Well, typically in an 8-hour shift, it'll do anywhere from 65,000 to 90,000.
65,000,
90,000
in an
images
8-hour.
in an 8-hour work shift. So a typical day here, it can get up to that amount of pages done.
Wow. So from here, obviously, you were also talking earlier, if something's not readable,
Mm-hmm.
is that where?
That's where that would come into play. So if one of these documents needed a rescan, we would definitely use that and to make sure that the quality of it is in acceptable conditions.
Okay,
for sure.
well, thank you, Jared. And
Absolutely.
when we come back, we're obviously going to kind of see where the brain, where all this electronically is actually going. So we're going to send it back to you at the studio, Mike and Scott, and we'll see you in just a little bit.
All right, thanks for that out there, Marylou. A lot of things going on at Stria. Nice to see what's going on over there. We do have phone tutors available until 5:30. We've got Debra in studio, and since Debra is here, we're going to put her back to work. Back to the board, young lady. Here we go.
She goes.
Once again, out of your math book. Ooh, some soup. Here we go. Here's the recipe. 4 cups of broth, 1 medium carrot sliced, 1 stalk of celery sliced, a half cup of uncooked egg noodles, 1/8 of a teaspoon ground black pepper, and 1 cup of some fowl. All right. Here we go.
Oh, sounds good.
There we go. Yeah, we'll keep it French today, eh? All right. Part A. Oh, let's take a look up here. They do have some information. Robbie is using the recipe to make the soup. He plans to make 6 batches of the soup.
That sounds pretty important. 6 batches of soup.
And he has 2/3 of a teaspoon of black pepper already.
Okay.
2/3 of a teaspoon of black pepper. So we saw what all the ingredients were needed. Part A, write an expression for how much black pepper is needed for all 6.
1/8 times 2/3.
Okay, so once you do that over there. So for 1 batch, you need 1/8. That's where that came from, right?
Yes.
1/8. And then how many batches do we need?
6.
6. So let's multiply that times 6 because we want to know that's how much we're going to need for 6 batches, right?
Or 6 over 1.
I like how you changed the whole number to a fraction. That was a good choice. 6 over 8. A little bit of reducing there.
3
over 4. You divided them both by 2. Okay, so we need how much black pepper?
6. Or no, 2/3.
No, hold on here. How much are we going to need if we want 6 batches?
Oh, 3/4.
3/4
But we
of a
only have
teaspoon.
2/3. Yeah.
How much do we have?
2/3.
2/3. Eek!
Yeah.
Is that good or bad?
Bad.
We don't know yet. Is it bad? I want you to prove it. I want you to go ahead and compare these two things. I'm going to put a big box in between.
Well, first, let's just take care of the problem first.
Okay.
So the first part of the problem says, write an expression where he can determine how much is needed. Have we done that?
I think we've done that.
So we've done that.
Okay.
Now let's move on to the next part.
Oh, sorry. We're already problem solving.
Easy now, brother. We only got a couple minutes. We'll get it all done. Here
All
we
right.
go. Let's take a look at the next one. Draw a model to show how Robbie can find the product from part A. So draw a model to illustrate what you just did.
Okay.
Can you draw a model with this big? Does it need to be in a rectangle?
It could be
Could be in a rectangle.
and
Here
then,
comes the model. Here she goes.
So I would write 2/3 and
Well, we want to make a model for what you just did here.
Oh, over here.
All this stuff over here. 1/8 times 6. So what kind of model are we going to do there? Okay.
And then you would multiply it over here, which would equal 3/4.
Okay. So we multiply those together. I like how you did that. Now we probably want to make that a little bit different because if you had this figure, your shape would probably be something like this. If this was 6 whole and this was 1/8, it'd be a lot skinnier, right?
Yeah.
But I know what you're thinking there. It's kind of like an area model. It's a good way to do it. Okay, I'm hoping we've attacked that one. We're still
Let's
thinking
take a
ahead.
look at part C.
All right.
Does Robbie have enough pepper for the 6 batches of soup? And then explain your reasoning.
Oh, I knew it was coming. I did.
So first we have to multiply these, which would be 9, and then 8.
Whoa, looks like exciting stuff. Tell us where those numbers came from, because you said we've got to multiply.
3 times 3
Okay.
would equal 9.
Okay,
and
so you did
then-
this bottom one times that top one.
Yeah, and then 4 times 2
Okay.
would equal 8. And 9 is always greater than 8. So 3/4 is bigger than 2/3, and you need 3/4. So for that reason, you don't have enough pepper.
We don't have quite enough. Now, what I'd like you to do also, I really like the way you did this. It's a wonderful, nice little shortcut. You can do this problem very quickly. Why does that work? Why are you allowed to go this bottom times that top, this bottom times that top? Why does that work?
Because when you multiply, that's what, I don't know.
That's a good question, huh? I think that's important to do. Well, let's see if we can figure out why this thing works, okay? If you were going to change both of these fractions into a new fraction with the same denominator, okay? So they both have the same number on the bottom. What number would you use on the bottom?
12.
I like that. You're multiplying them together, you would use 12. Okay.
And so you made this one 4 times, or you made this go 3 times. So 3
So
times
show us that.
3 would be 9.
It would be times 3 here and times 3 here.
And you made this one 4 times bigger, so this one also has to get 4 times bigger, which would be 8.
So what you're really doing when you're doing this little shortcut by multiplying back and forth, what you're really doing is you're changing both of those fractions to new fractions with the same denominator, and you're only comparing the numerator, right?
Yes.
And that makes sense because that's all you have to compare. The denominators are the same, you only have to compare the top. And you can still stay with that same sign. If you were going to reduce 9 over 12, what would you get?
You would get 3/4.
You would get 3/4. What if you reduced 8 over 12?
You would get 2/3.
Get right back to where we started. So I think that you did a good job reasoning through that, and we found out now, you can even tell your friends, why do we do this? Well, because really you're making some new fractions. Good job on that one.
There you go. And if you're able to go ahead and just multiply and get those numbers easily, go ahead and do that.
That's
I always
right.
say, as long as you understand what you're doing, take that shortcut, cut that middle step out of there.
Yeah.
So nicely done. So I have a bonus part of this problem for you. All right. Let's go ahead and take a look at the recipe once again. It says that we need a 1/2 cup of uncooked egg noodles.
Oh.
Now, that's for 1 serving, right?
For one
How
serving.
many do we want? We want 6, right?
Yeah, we want 6.
So how many cups of uncooked egg noodles do we now need for 6?
So if you need 1/2,
1/2. You tell me what you're right. I'll be your scribe.
you want 6 in total. You
Okay.
would have to find, what can you multiply to get 6? Or
You want 6 batches, though,
you
right?
want
Like we did up there.
Yeah, you want 6 batches.
You want to finish that part off there?
So
Put it over 1. Good.
that would still equal 3.
Hey, look at that. It's like almost like half a 6. Good
Yeah,
job.
so-
Nicely done. I just wanted to throw a bonus part in there for you. Hey, we do have phone tutors available until 5:30 this afternoon. We have one more opportunity to head out live with Marylou.
We are back live at Stria, and I have another special guest, Robert Cleveland. Can you tell everybody what your position is and what it entitles?
Sure. I'm the Director of Information Systems. So my department manages all of our IT infrastructure, and we work on automation projects, processing documents using technology and artificial intelligence for our customers.
So does that mean that you need to be looking at a lot of programs, or are you looking at machines that process that?
Most of the time we're looking at machines that process documents.
Okay.
Some of them are physical servers and a lot of them are virtual now.
How did you get here? What brought you here?
Well, I actually was working on my master's degree and was substitute teaching at Actus Junior High, and that's where I met Jim Damien's wife and mentioned that I was looking for a job in technology, and she said, well, my husband's looking for people. So I've been here for almost 11 years now.
Oh, wow. So you almost started with the company itself.
Almost. You know, I started scanning paper, and here I am now.
So we were talking, we kind of went through all the process. We scanned. So from there, where are we at now?
Yeah, so every image we scan ends up right here.
So I'm kind of like shocked when I first saw this because I expected something like huge, something really big, but it's not.
Yeah, it really isn't. You see, each of these is a server, and one of these little things here can hold, 1 to 6 actual machines on it
So
through virtualization.
what do you mean by machines?
So an actual computer. So this server has about 6 computers running on it at any given time.
So how many documents, I should say, how many documents do you think one will hold?
So these and these are the actual storage. So each one of these bays right here is a hard drive. And as far as physical pieces of paper, with our current capacity, we can hold about 2.5 billion sheets of paper.
Now, you were saying, earlier we were saying that you don't keep it all. Sometimes
No, we
once
don't.
you get it, you just ship it off.
Yeah, our goal is to keep things moving. So we always want to be pushing documents out as they're being processed. Most of our customers are using cloud-based systems. So we're always pushing documents up into those systems. We're taking all of the data that's been assigned to those documents and we're tagging those documents in the system so that when somebody needs to find something, they can just put in a few search terms and there's the document they're looking for.
So if I wasn't cloud-based, okay, and I had you do all of my math papers, computer crashes, okay, because you give me all my stuff back, my computer crashes, everything is gone. Could I come back to you to retrieve it? Would you still have it?
Probably not. We typically keep things for around 30 days after we end a project, and then we're getting rid of it.
So best thing is have it on the cloud.
Yeah. Yeah, most cloud systems have redundancy in place. I know we provide cloud systems for some of our customers, and yeah, we always have redundancy set up. So maybe the actual data is stored on the East Coast. We're always backing that up to the West Coast.
Really interesting. Well, I'm going to pull Jim back in here real quick. Thank you so much.
Yeah.
Now, Jim.
Yes.
How can these kids, if they were interested in this type of technology, what course of actions could they take?
Well, keep learning their math, keep studying, and we're hiring all the time. So if people, as they're graduating high school or as they're nearing the end of their high school career and they want to do an internship or apply for a job once they graduate, we're open for business. We have multiple shifts, and so this is a great entry-level position for anybody that's got an interest in technology to come in and get started with a career here at Stria.
Now, you have a really high percentage of Kern County high school graduates, correct?
Yeah, we did a survey, and 80% of the people that work at Stria came through the Kern County high school system. So we're really, the school system's doing a great job. They're producing people like Robert Cleveland here.
Yes.
Yeah.
Well, thank you so much. It has been a pleasure.
Our pleasure.
And thank you. It's been great. And that's it from Stria. Again, check them out online. Is there a web page to go to?
Stria.com. We're open for business there 24/7, so come on by.
There you go, and we're going to send it back to the studio.
All right, thanks for that. Nice to meet everybody over at Stria, and I know that Marylou had a wonderful time, and we do appreciate Stria being part of our program today. We do have phone tutors available today until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. We would like to say thank you to Debra for coming in, and because you did an outstanding job today, you now are going to get yourself an official uniform of Do the Math. Do you know what that means?
Like, I'm an official student.
You are an official student, correct? And now you are an ambassador for Do the Math. Do you know what that means?
No.
An ambassador means that you need to spread goodwill about what you're representing.
Okay.
All right? So that means if somebody's having difficulty with their math in class, or you see somebody at school and they're having difficulty, you can offer to help them. And then what else can you let them know about?
You can go on this every Tuesday and Wednesday.
That's right. You can say, hey, you know what? You can call Tuesday and Wednesday. You can call the old man over at Do the Math, and they'll help you out do your math problems and stuff like that. And they'll go, how do I do that? And you go, here's my shirt right here. Phone numbers are on there. They can go ahead and copy that down.
Which means you have to wear that shirt every day from now to the end of the school year.
Every Tuesday and Thursday or whatever. You can wash it once in a while, all right? Wear it once in a while, okay? And then just tell people about Do the Math. You can do that?
Okay.
Deal?
All right.
All right, nicely done. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.